In this video, we'll discuss problems and conceptual exercises of Chapter 3 from the book James S. Walker. So here in this question they are saying that there's a vector and each component of that vector is doubled. So let the vector be a vector. You can take any vector. And its component we have ax and ay in x and y direction respectively. Now each component of a vector is doubled. That means it becomes 2 times. This is what they are saying. Now there are 2 parts in this question that we need to solve. So in the A part they are asking by what multiplicative factor does the magnitude of the vector changes. So you should remember one thing, that the magnitude of vector is given by under root ax square plus ay square. Now when the each component is doubled, then this would be under root 2 times ax and its whole square plus 2 times ay and its whole square. So this would be equals to under root 4, I can take common, ax square plus ay square. So this would be equals to 2 times under root ax square plus ay square, and this is nothing but the magnitude of a. So this becomes 2 times the magnitude of a. So this would be the answer for the A part. Now next we can solve the B part. Now in the B part what they are asking is by what multiplicative factor does the direction angle of the vector changes. So direction angle, basically this is theta equals to tangent inverse the y component over the x component of a vector. This is what we studied. Now when the component of a vector is doubled, so this theta would become tangent inverse 2 times ay over 2 times ax, but this 2 and 2 will cancel and we'll get tangent inverse ay over ax, which is nothing but theta. So when the component of a vector is doubled, the direction of a vector will not going to change, but its magnitude would become 2 times. Now here in this question we are given with this figure and we need to rank all these vectors in the order of increasing value of their x component. So let us try to figure out their x and y component for each vector. Now for a vector, this arrow will show its x component ax, and this would be its y component ay. Now for B vector, it's along the positive x direction, so this itself is the x component, no need to show. Now for similarly we can draw for C and D also. So I've drawn the arrows. This would be cy and this would be cx, this would be dx, and this would be dy. Now by seeing all these the vector components, we see that the length of dx is maximum, but it is along the negative x direction, so this would be the least. So first it will come dx, then after dx this would be cx, and after cx this would be bx, which is basically the B vector, and finally the maximum x component would be ax. So this is the increasing order of the x component. So here we are given that there's a press box at a basketball park which is 44.5 feet above the ground. Let me take it to be h, which is 44.5 feet. Now a reporter in the press box looks at an angle of 13.4 degree below the horizontal to see the second base. So let's try to understand this question by using this figure. So here we can consider this is our press box, which is 44.5 feet above the baseball park. So let this height be h, which is this value. Now a reporter is sitting over here, and a reporter in the press box looks at an angle of 13.4 degree below the horizontal. So its line of sight would be something like that. And this angle theta below the horizontal, this is theta, and this theta we are given to be 13.4 degree, and this we have taken to be second base. Now the question says, what is the horizontal distance from the press box to the second base? So what they are asking is, they are asking this distance. Let this distance be d. Now this question is pretty simple. Before watching the solution, you can try on your own. So if this angle is theta, this angle would be 90 minus theta. Let it be theta dash. So theta dash would be 90 minus theta, which is 13.4. That is equals to 76.6 degrees. Now we can use our trigonometric formulas. Let this be A point, let this be B, this be C, and this is a right angle triangle. So we can write that tangent theta dash will be equals to perpendicular over base. Perpendicular we have D, and base we have H. So the distance d would be tangent theta dash multiplied with h. Now we can put the values. H we have 44.5 feet, and tangent theta dash is 76.6 degrees. So this would come out nearly 187 feet. So this distance is 187 feet, and this is what they are asking. So here the question is saying that there's a road that rises 1 feet for every 100 feet traveled horizontally, and this kind of road is said to have 1% grade. What they are saying is, suppose that you are traveling on an inclined road, and suppose that the horizontal distance traveled by you is 100 feet, and the vertical distance gained by you is 1 feet. So this kind of road is said to have 1% grade. Now then they are saying that there is a road that have 6% grade. Then at what angle is this road inclined above the horizontal? So 6% grade means a road gains 6 feet in altitude for every 100 feet traveled in the horizontal direction. Let me represent on the figure also. So let this be your road, and horizontal distance traveled by you is 100 feet. Then the altitude gained by you would be 6 feet. This is what 6% grade means. Now the question is asking this angle theta. This angle theta. This is what we have to calculate. Pretty simple question. Tangent theta we have y over x. The vertical distance over this horizontal distance. So vertical distance we have 6 feet. Horizontal distance we have 100 feet. So from here theta would be tangent inverse 6 over 100. So that would be equals to 3 degree. So this angle theta is 3 degree. So here in this question we need to find the x and y component of a position vector r, and its magnitude we have 88 meter. Now there are two parts. In the first part, the angle relative to x-axis is 32 degrees, and in the b part we have 64 degrees. So we're going to solve the a part first, and in the a part the theta is 32 degrees for the position vector r, and its magnitude is 88 meter. So let us try to represent this position vector on this coordinate system. So this would be, we can take it to be r vector, and this is the origin. Now this angle theta we are given to be 32 degrees. Now the x and y component we need to find. So x component we know it's r cosine theta, and r we have 88 meter, cosine theta we have 32 degrees. So that would be equals to 75 meter. Next ry, the component in the y direction, is r sine theta. So 88 sine 32 degrees. So this comes out to be as 47 meter. So this is the answer for the A part. Now next, the B part. Now here everything remains same, but this angle theta changes to 64 degrees. So we have this coordinate system. Now this theta is increased, so this would be our position vector this time. And this is our origin, this is r vector. And this theta we have this time 64 degrees. Now to find its component, we have to use the same formula, r cosine theta, r sine theta. You can do it on your own. I'm just writing the values. Rx, we will get this value to be nearly 39 meter. And Ry, you'll get this value to be nearly 79 meter.